Hello everyone and welcome to St. Andrew's Institute of Technology and Management. St. Andrew's Institute of Technology and Management is the best engineering college in NCR, in Northern India and entire India. It is the best career choice that you can make for yourself or for your children. The subject that we shall be looking forward to here is Principles of Operating System. The code is PCC CSE 206G. This is a CSE 4th semester subject in accordance to MD University Rohtak. The topic discussed in this video shall be thread, the definition, the various states, benefits of threads, types of threads, multi-threading. I, Shalini from CSE department, shall be taking you forward. Threads. Now, what is a thread? A thread is a basic unit of CPU utilization. It consists of a program counter, a stack, and a set of registers, and a thread ID. So, a thread is a path of execution within a process, right? So, it is smaller to a process. A process can contain multiple threads. So, in other words, we can understand that one process can be said to be made up of one or more than one threads, right? The primary difference between process and thread is that threads within the same process run in a shared memory space while processes run in separate memory space. In the earlier video we studied the processes and we say that they have different memory space, but this is not the case for thread. In thread they will run within the same memory process, so they will not be having independent for each and every thread. They will not have different memories, right? So they'll be sharing their code section, their data section, their open files, right? So threads are not independent of one another like processes are, and as a result threads share with other threads their code section, data section, and OS resources. But like process, a thread has its own program counter, register set, and stack space. What are the advantages of thread over process? The first is responsiveness. See, if a process is divided into multiple threads, if one thread completes its execution, then its outputs can be immediately returned, right? So it becomes more responsive. Faster context switch, very general understood. Context switch time between thread is lower as compared to process because they are larger in size, right? So it will have faster context switching between them. The process context switching requires more overhead from the CPU, wherein in thread this is not the case. So context switching is faster. Next is effective utilization of multiprocessor systems. If we have multiple threads in a single process, then we can schedule multiple threads on multiple processor. This will make process execution faster. Very well clear. See, multiple thread on a single process will automatically schedule on different multiple processors, so it will make the execution faster and more efficient. Fourth is resource sharing. Resources like code, data, and files can be shared among all threads within a process. See, stack and register can't be shared among the threads also. Why? Because different thread will be executing different tasks from other thread. So stack contains the all local variables, so it puts into its stack and then it takes out from the stack, and registers also does the same, so they will not be shared, right? Rest their code section, data section will be shared, memory will also be shared. Communication between multiple threads is easier as the threads share common address space, while in process we have to follow some specific communication technique for communication between two processes. The last is enhanced throughput of the system. See, if a process is divided into multiple threads and each thread function is considered as one job, then the number of jobs completed per unit of time is increased, thus increasing the throughput of the system, right? So this will increase your multi-job scheduling. Thread state. When a thread moves through the system, it is always in one of the five states: the ready, the running, the waiting, delayed, and blocked. And of course, it will be created also and deleted also, right? So we'll study all this one by one. How it is going through from one state to another state, to the next, how it is moving in and out of them, right? And so from creation, see in this figure we can see from creation it is going to ready, from ready to running, then from running it is coming to waiting, delayed and blocked, and then again it is going to ready, and then from ready to running, and then finished. So we see here how it will be done. Right, the first is when an application is to be processed, then it creates a thread. It is then allocated the required resources and it comes in the ready queue. Right, that it is ready queue means it is waiting for its turn to get CPU. Next is when the thread scheduler, like a process scheduler, assign the thread with processor, it comes into the running queue. When the process needs some other event to be triggered, which is outside its control, right, like another process to be completed, then what it does, it transitions from running to the waiting queue. The next is when an application has the capability to delay the processing of the thread, right? It, when needed, can delay the thread and put it to sleep for a specific amount of time. Then it is said to be in a delayed state or in a delayed queue. It is one. An example is like of delaying thread is snoozing of an alarm. After it rings for the first time and it is not switched off by the user, it rings again after a specific amount of time. So during that time, the thread is put to sleep, right? Okay, next is the block state. So when thread generates an input output request and cannot move further till it's done, it transitions from running to the blocked queue, right? So after the process is completed, the thread transitions from running to the finished. So we see the difference between a waiting and a blocked. The difference between a waiting and blocked transition is that in waiting, the thread waits for the signal from another thread or waits for another process to be completed, right? Meaning the burst time is specific. While in block stage, there is no specific amount of time. Okay, it depends upon the user when it wants to give you the CPU or when it wants to give any sort of work to you. So it is entirely dependent on the user with no specific time boundary. Where in waiting process it is waiting, it is waiting for its thread, its time to get completed. The next is that is thread control group. See, in order to execute all the processes successfully, the process needs to maintain the information about each thread to thread control blocks, like the one we did in the PCB, that is process control block. So it's similar to that. Okay, next we come to types of thread. There are two types of thread. The first is the user thread and the next is the kernel thread. Okay, we'll see the difference between the two. See, user thread versus kernel thread. User thread are implemented by the user, wherein kernel threads are implemented by the operating system, right? The operating system does not recognize user thread, wherein kernel threads are very well recognized by the operating system, because operating system is the one that is being implementing the kernel threads, right? So the implementation of user thread is very easy. Why? Because it is done by the programmer, wherein the implementation of kernel thread is very complicated and it is handled by the operating system. The context switch time is very less in user threads, whereas in kernel thread the context switch time is very large. Context switch does not require any hardware support in user threads, wherein in kernel thread it needs hardware support. If one user level thread performs blocking operation, then entire process will be blocked. Whereas if one kernel thread performs blocking operation, then another thread can continue its execution. User level threads are designed as dependent threads, whereas kernel level threads are designed as independent threads, right? See, it is dependent, the user threads are dependent. That is why, when it blocks when one user thread does blocking, so the entire process is getting blocked down. Wherein kernel thread is independent, that is why if you block one kernel thread, it doesn't affect another thread, right? And what are the examples of these? User thread example is Java thread, the POSIX threads, and this kernel threads are made for Windows and Solaris. Okay, next we come to multi-threading. See, traditional heavyweight processors, they have a single thread of control. There is one program counter and one sequence of instruction that can be carried out at any given time. Multi-threaded applications have multiple threads within a single process, each having their own program counter, own stack, and own set of register, but sharing common code, data, and certain structures such as open files. Right? This we discussed earlier also, no? The very first slide that we were discussing process and thread. Okay. See, it is very clear from this figure. See, the first one on the left side, this figure is having a single threaded process, and the right one is multiple threaded. So I can see only a one single thread in this, in the left side, wherein there are three threads if I see on the right side. Now if I look at the topmost block, and what is there? There's code, data, and files, and then the register and stacks, all belonging to this thread. Wherein if I look at the right, then I see that the topmost block, code, data, and files, is shared by all the three threads. Right? See, this code, data, and files, there's no bifurcation in between. This is all commonly shared. Whereas register and stack for all these three threads are different. Right? For the first one also I have a different register stack, second one also, third one. So it is very clear from the figure, no? That this code, data, files will be shared between the thread. They will have shared, wherein they will have their own set of registers and stacks. Right? So now we will see how this multi-threading will go. Right? So what are the motivation behind it? See, threads are very useful in modern programming whenever a process has multiple tasks to perform independently of the other. Right? So it will really help in modern programming because we want to execute multiple tasks. So that is a motivation for execution of multiple tasks. Okay. This is particularly true when one of the tasks may block and is desired to allow the other task to proceed without blocking. Right? See, if it is independent, like if the two tasks I have to make independent, so what I do is like I divide it into two threads, so the two of them execute independently, and the execution of one does not block the execution of other. Right? So this was the, I could say, need also, motivation also, and this actually, it was a thirst as to why multi-threading was introduced. See, in this example, what it says, for example, in a word processor, a background thread may check spelling and grammar, while a foreground thread processes user input, that is keystroke. Right? So one is, the background thread is doing spell check and grammar, or while the foreground is taking the inputs. So there are two threads, and yet there is third thread. There's third thread also, which is loading images from the hard drive. So there are three, and a fourth, which is doing periodic automatic backup of the file being edited. So this is very nice. See, so how many four threads I have in here? I have four in a single word processor. What are they doing? One is checking my spelling and grammar, the other is taking my input from user, the third is loading images from the hard drive, and the fourth is automatically backing up. Right? So the four threads going on one by one, all independent of each other. Now another example is a web server. See what happens in a web server. The multiple threads allows for multiple requests to be satisfied simultaneously without having to service requests sequentially or to fork off separate process for every incoming request. Right? So there are in a web servers also, there is one server has to serve multiple clients. So what it does is that it allows for multiple requests that are to be satisfied simultaneously. So I would be having like a one to many sort of a relationship, wherein one server will be servicing different clients. Right? And without this having to service requests sequentially. So it does not need that okay, I'll do the first client one, then second client one, or wait, I will fork out separate process for each incoming request like it was earlier. So the later is how this sort of thing was done before the onset of threads. So a daemon would listen at the port, fork of a child for every incoming request to be processed, and then go back to listening to the pod. Right? So this is how it was done earlier, but now it is not so. We can do it simultaneously with the help of multiple threads. Okay, so these are all the benefits. There are n number of benefits of multi-threading. The first is responsiveness. See, one thread may provide rapid response while other threads are blocked or slowed down doing intensive calculation, right? So you can at least start getting the response from one thread which has completed its execution. So this increases the responsiveness of the system. The next is resource sharing. See, by default, threads share common code, data, and other resources, which allow multiple tasks to be performed simultaneously in a single address space, right? So we saw in the figure also, there was the single memory space, the single code section, the code section was there, right? And all they had the shared files also. So resource sharing is very, very advantageous. Economy. Creating and managing thread is much faster than performing the same task for process, right? This we done also, the advantage of process threads over process also. So, and this is the advantage of multi-threading also, right? So it helps to create and manage thread which are faster in performing the same task as compared to a single process doing it. Next is scalability, that utilization of multiprocessor architecture. See, a single threaded process can only run on one CPU, right? No matter how many may be available. This is very, very clear to you. Single threaded will run only one CPU, right? Because it is the smallest unit of execution into CPU. So even if there are n number of CPU that are available on which I can run, so single threaded way will make all of them redundant, right? So whereas the execution of a multi-threaded application will split among various available processors. So if it is multi-threaded, it can be divided into all the n CPUs. Okay, the note there is that the single threaded processes can still benefit from multi-processor architecture when there are multiple processes contending for the CPU. That is when the load averages above some certain threshold, right? So that is the thing that can be excluded. Okay, next we come to multi-threading models. See, there are two types of thread as discussed earlier that are to be managed in modern system: the user threads and kernel thread. This we discuss into type of thread. Now what it says is that user threads are supported above the kernel without kernel support. So these are the threads that application programmers would put into the programs. So these are user defined threads. So kernel threads are supported within the kernel of the OS. So all modern OSs, they support kernel level threads, allowing the kernel to perform multiple simultaneous tasks and to service multiple kernel system calls simultaneously. Okay, so in a specific implementation, the user thread must be mapped to kernel thread using one of the following strategies. And what are they? The first one is many to one model. In many to one model, we have many user threads that are mapped to a single kernel thread, right? So thread management is handled by the thread library in user space. Okay. However, if a blocking system call is made, then the entire process block, even if the other user thread would otherwise be able to continue, right? Because a single kernel thread can operate only on a single CPU, the many to one model does not allow individual process to be split across multiple CPUs. This is very well understood because there is only one single kernel that is doing it, right? So even if you're doing it from the user level, you are actually employing it, it is being of no use. Green threads for Solaris and GNU portable thread implement the many to one model, right? Okay, then we come to one to one. One to one, it means one separate kernel thread to handle each user thread. So one user, one kernel. This overcomes the problem listed above, involving blocking system calls and splitting the processor across the multiple CPUs. However, there is an overhead of managing the one to one model, right? So it is overhead is more, involving more, slowing down the system. So most implementation of this model place a limit on how many threads can be created. Linux and Windows from 95 to XP implement one-to-one model for threads. Next is many-to-many model. The many-to-many model multiplexes any number of user thread onto an equal or smaller number of kernel threads, right? Combining the best features of one-to-one and many-to-one models. So users have no restrictions on the number of threads created. Blocking kernel system call do not allow the entire process. So processes can be split across multiple processors. So individual processes may be allocated variable number of kernel thread, right? Depending upon the number of CPU present and other factors. So you have many users and many kernel, so it can choose in from there. So in the diagram also it is clear. See, the one on the top left is a many user thread and one kernel thread, so many to one. The one on right is many user and many kernel, so many to many. The one on the lower side is one this user thread corresponding to one kernel thread, so 1 to 1, right? So this is, we are done. So this is important questions. What are threads? What is the difference between process and thread? What are the benefit of thread? What are the various states of thread? The different types of thread? What is multi-threading and what's the benefit of multi-threading? So this is all that we are done. Thank you so much.